Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30pm local time. We'll see you soon. This is VK7 OTC.
You're in front of the camera.
Of Peter's books.
Now Larry.
So I brought up one of the books, took a snapshot of it on the iPad, and with the pen had him sign it.
We're on. We're on. We're on. Peter, welcome.
Thank you, Justin.
A lot of you probably know Peter Parker from a myriad of videos and books and all sorts of things. So we're privileged tonight to have Peter here, and I find out tonight that we're actually, I hope we see more of Peter, because Peter's mum actually lives at Cygnet. So, which is excellent. So Peter's agreed to give us a bit of a talk on the fun of QRP. So no further ado, I'll hand over to Peter. Thank you very much.
Okay, thank you, Justin, and thanks for having me here. And well, fun of QRP. Well, some people think of QRP as a bit of a futile exercise. Bang your head against the brick wall. You hear people moaning all about bad band conditions and how they can't hear anyone, and they expect even fewer would hear them, especially with low power. Tonight I'll talk about that you can still have fun even with low power, and and some of the things you can do with it, and particularly the promise of some of the new digital modes, which I'll talk about. As to what is QRP, well, a lot of the QRP clubs around the world, there's no concrete definition, but they often go by 5 watts of CW, 10 watts of SSB, 5 watts digital modes. That's like there are QRP awards you can get, QRP DXCC from the ARRL. That's based on that sort of low power. So roughly foundation license power or a bit less for CW. You can do pretty much any amateur activity with QRP, and some activities are best done with QRP because of limitations with what you can take when you go portable. So the sort of reasons, well, maybe you've already worked DXCC with 100 watts, 400 watts, whatever, and you want to do it again but have a bit of a challenge seeing if you can do it with low power. That might be one motivation. Homebrew gear, I find that building power amplifiers are always a bit of a trouble, and they tend to have outputs on more frequencies than what you're aiming at, and of course there's heatsink problems. You need more complicated power supplies, or you could just be lazy and just forget the final amplifier and just connect your low pass filter up to your driver stage, and then you have a QRP transmitter. So when you're building a transmitter, you start start from your lower level stages, and then you get to, when it's 1, 2 or 5 watts, and you think that's enough, I'll put it in a box, and besides you've run out of room in your box to put all the other final stages, so that's your project done, and it's QRP. So yeah, homebrewing is a great strength of QRP. You can get some incredibly simple designs that work quite well. Some are incredibly simple and do not work well. I'll talk about those later on. QRP is great for battery or solar portable operating, because you don't need to worry too much about huge generators or big power supplies, so it's just simple if you can take a small battery and you can be on the air for hours. There are special awards, particularly Summits of the Air, which we have plenty of here in VK7, VKFF and national parks. A lot of people that go into those are operating QRP, particularly as they've just got a small station that they can carry. Weak signal data modes are hugely efficient. You can get you're tens of dB better off than SSB for a similar path, and QRP can work with those, and also HF Pedestrian Mobile, which I've done a bit of. As to whether it works or not, it is probably a bit more subject to conditions than higher power. There's less leeway, particularly if the receiving station has more noise, but you can still have worldwide contacts on all modes. Easiest with digital modes, CW, then SSB. SSB is still possible, but certainly even despite the conditions that people talk about, routine contacts within VK and ZL are possible on all modes. Find very rarely does one not make contacts, provided you pick your band right, your antenna right, time of day, and the location can help as well. And mobile and portable operating can be quite successful. And there's also the thrill of contacts with gear that you've built yourself. As to what you can do with how to get started on QRP, easiest is almost all 100 watt transceivers. You can turn the power down to 5 or 10 watts, and yes, you could make contact with 100 watts and then see if people can still hear you at 5 watts, even less. 1 watt, 100 milliwatts, 20 milliwatts, you never know. I've had SSB contacts with 20 milliwatts on 40 metres, over hundreds of kilometres, so yeah, that can be possible. Another possibility, well, the 100 watt transceiver with the power reduced, the big issue with that, especially if you're operating portable, is the receive current consumption. They can draw more power on receive than a dedicated QRP transmitter will use on transmit. So great for home use, maybe in the car, but for portable use, it's probably better to have a dedicated QRP rig. And I'll talk about some of the popular models later on. You can get them either new or used, or you can even get kits, either kits that require very little electronics knowledge to put together, others a bit more sophisticated, or you can even build your own from scratch. So there's huge choices with QRP. As for QRP transceivers, the most famous is probably the FT817, FT818. If you've already got an FT817 ND, it's probably not worth getting an FT818. The only difference, I think, is that it might be 1 watt extra power. The battery pack, instead of being absolutely terrible, is now merely mediocre in its capacity. I'll talk about powering QRP rigs later on. But yeah, if you want a basic do anything or do everything package, then the FT817, 818 is a good choice. There's a new ICOM coming out, quite a bit more expensive, ICOM 705. That's a possibility. Yeah, so the Yaesu is one choice. It's been around since 2001. So for a transceiver, if you think about, we thought that the FT101 series lasted a long time in the 70s, 80s, or whatever. But the FT817 is probably Yaesu's longest running transceiver. And if you count the 818, then it's been going for the better part of 20 years. So it's amazing. And then there's the Elecraft, if you've got a bit of money to burn, and if you really look after your equipment. Like there's some people that have these nice cases and look after their equipment and only use them on parks. So the problem, Elecraft's a great rig as far as their RF performance goes. If you look at the specifications, yes, they are better than the FT817, 818. bit more output power. I think it's maybe 10 or 15 watts. I've got a speech processor, I think, on SSB. Bit lower receive current consumption, which is a big benefit. I think it's about 150 milliamps versus 300 or 400 for the 817. But they don't have quite as many bands. They don't have the 2 meters, 70 centimeters. And also when you look at them, they look like, to my eyes, they look like a bit of Swiss cheese. Like, you look at all the little holes around the size of a KX3, and you think, if you're on a beach and it's blowing a gale, and sand will get in absolutely everywhere, and people, see my videos, they see all this sand crusted around the display of my FT817, still hasn't missed a beat. I would not dream of getting an Ellicraft, particularly given its price, and taking it into the places that I go. So if you are the type that operates a long way from sand, you've got everything all in nice cases, everything's all in shelters and tents and things, then the Ellicraft might be a good choice for you. There's a KX2, which is like a junior KX3, a little bit smaller, fewer bands, but still a bit more expensive than the 817, 818. So good rig, but treat it carefully. Then there's other types. There's a Chinese model. I don't know if it's still a current model. It's only 80 through to 10 meters. It's got a few rough edges. It's only got a small number of low-pass filters. Before buying, yes, it is cheaper than the Yaesu, but I'd have a look at the reviews. People might comment about usability, quality control, etc. So the ones I've heard have been on the air sound okay, but yeah, my bias would be towards the Yaesu. Then for the CW buff, there's these tiny LNR type transceivers. These are absolutely ideal if you want something that, if you're going on a multi-day hike and every gram is critical. You've got a tiny thing, it's not much bigger than a matchbox, it covers 3, 4, 5 bands. It's CW only, it's not cheap either, $300 to $400 US, but on the other hand, it's if you're just CW, if you just wanted to maybe keep skids with people, the only thing is that, and I'll talk about that later on with the operating, and I write about it a lot in the book, a lot of QRP is actually listening, which means that you're tuning around the band, which means your ability to do that in a transceiver is really important. And when you look at the LNR, I can't see any tuning knob. I can only see up-down buttons, and I would imagine that I haven't heard of them being worn out. But if you are scanning the band in 1 kilohertz increments or whatever a lot, then I would rather a tuning knob for easy tuning around the various bands. So maybe so you wouldn't get it for if you're a hardcore contester or even a DXer, but if it's just to activate a Summit with the absolute least amount of equipment and very lightweight, and you're into CW, then it might be a good choice to go. Then there's also some QRP rigs in the used ICOM 703 from the 90s. That looks a lot like the ICOM 706, which is a very successful ICOM rig. But they also had a QRP version. You might sometimes see those on the second-hand market. I think it only goes up to 6 meters, unlike the 706. Sound good on the air. They are quite heavy, especially compared with the 817, and they've got a bit more receive current use. So maybe not the greatest for backpacking. Then, of course, right at the bottom, and there's, I noticed in the next room there's the model up from this. This is the original FT7. Weighs a ton. If you look at the volume of it, it's probably about 8 or 10 times the size of the volume of the 817, and it does half the number or a third the number of bands. But analog dial, but it's a good receiver. If you happen to have one you haven't used for years, then that is not a bad QRP rig. So there's options with commercial gear. The other possibility is something that involves your own practical involvement. The Indian kit called the Microbit X, 80 through to 10 meters. So bearing in mind that the power output does drop off at the higher frequency ranges, so you'd mainly use it for 80 and 40, maybe 30 to 20 meters. It's a pre-assembled kit from India, designed by Ashar Farhan, VU2 ESE, and it's pretty much all pre-assembled. Like, you see all those surface mount parts, all the toys. that's all assembled when you get it, and it's surprisingly low price. It's a bit more than QRP output. I think it depends on your supply voltage, but I think it's like something like 7 or 8, maybe 10 watts. And there is a bit of soldering. It probably takes a couple of hours. You need to find your own box, but you can get boxes that are made for it. It won't be quite as small as the FT817, but it could be made lighter because there's only quite a small heat sink on the 2 final transistors on the right of the screen. So you could possibly make it lighter than the 817, so that could be a consideration. It's a little bit clunky on CW, and there are all sorts of mods. There's a huge user group, email list, Facebook groups, all sorts of ideas and things. Like it's like if you're technically inclined and you like the idea of modifying little surface mount things, there were some issues with some of the various versions. I think we might be up to version 5 or 6 now. But yeah, it's the great thing about it is it's very low price. So it's and I've had some good contacts with it. Another possibility is you could a bit more personal involvement is get a full kit. We have in Australia QRP, which is basically Leon Williams VK3YE. I know that there are at least several of the MDT transceivers in Tasmania. I've worked 1 or 2 for Melbourne. That is basically a little 40-metre double sideband transceiver. It's out a couple of watts. And it uses a ceramic resonator, so it doesn't cover all of the band. There are mods you can do to cover I think it covers about 40 kilohertz as it comes, but if you change it, put an extra capacitor or whatever and put a switch, you can get maybe an 80 kilohertz or so segment of 40 meters. So it doesn't cover all the band, but you can get some quite good contacts with it. However, if you, it's only a little bit more, $115 instead of $80. I would strongly suggest instead you look at the new one called the DCT, which stands for, it's still double sideband, but it's 5 watts output instead of 2 watts output. It's got a DDS VFO, nice central display there. It also does CW. I tried it during one of the contests and it works surprisingly well. Yes, the receiver is direct conversion, but the bandwidth, yes, the bandwidth is twice as wide, but it really does handle really well. It feels, sounds like a commercially made rig, and I've had a lot of success. I think it might have been the RD contest or one of the contests I went in it and did quite well. I've done a review of both those rigs on my YouTube channel. With the DCT, it is a single band, or both the rigs are single band. With the DCT on the right, you can either choose 80 or 40 meters, so there's a choice there. But that is a good rig to, and I think all the surface mount parts are already built on the board, so it's just the through-hole parts. But yeah, good. Another thing from QRP, especially if you've got your own box, is an MST3, which is an SSB rig, crystal filters in them. Again, single band, costs you a bit more. But the good thing about that, it draws less current on receive than the FT817. So if you wanted a dedicated rig for SOTA portable operating, where you want low power consumption, good receiver, SSB as well, then that's something to consider. There's also the QRP labs. Quite a few people have built them, more for a CW enthusiast. That's Hans Summers. Incredibly low cost, $49, and it's 5 watts output on CW as well as Whisper. So you can be your own Whisper beacon there. There's a lot of very clever software tied up with the DDS. It's called the QCX. I don't think it doesn't come with a case, but I'm sure there would be case options, or you could build your own, and you can choose from a single band. Then there's the ones you see on eBay for like, that's $3.63. They might be a little bit more, but a complete transceiver for $3.63. It's almost unbelievable. You can even, you probably can't buy the individual parts. Like you get a BNC socket, an LM386, and both of them over the counter, they would cost more than $3.63, but here you've got a complete transceiver. Does it work? Well, sort of, but it's a bit frustrating. Your very low power output, less than half a watt. It is crystal locked, which is a really big disadvantage. I'll talk about that later on. Basically with QRP, you've got to go and search for other people to call and make contacts. Your chances of success are much lower if you are trying to rely on other people to find you, which you basically are with crystal control. The receiver is also very poor. It's got quite a wide bandwidth and it can be overloaded. So I wouldn't recommend it as a practical QRP rig if you want to actually have contacts and get success. Although your half watt output, that will still be heard over several hundred kilometres. Yeah, you require a lot of planets to align to easily get a lot of contacts on it. But if you want something, if you're starting out in building, in construction, if you want a simple project, or even if you wanted to build a code practice oscillator that happens to transmit, then your Pixie is a possibility. You could just have a meter or so of wire and talk across the room and build a proper antenna and talk a few kilometres. So yeah, it's you'd get disappointed if you expect really good results, but if you build it as a construction project, learn how to build, learn how to solder, it's fantastic value for that. And there are various modifications you can do with the Pixie. I've described a few on my website. One of them is I converted it into an AM transmitter on 160 metres, so I did that and it sounded surprisingly good. And I think because I used the LM386 as a modulator to, it meant I didn't no longer have the receive function, but I could use I cut a few tracks on the board and I could use that to directly modulate the final stage, and it sounded quite good. Another possibility is making it a frequency agile receiver by putting in a ceramic resonator so you can tune a bit of 40 metres. So yeah, it's a fun little project. If you're mainly an operator, there's better options. Another thing as well, which is coming in quite recently, there's now a few digital mode transceivers. Morse code's an efficient mode, but not everyone likes it, and you can now you've got digital modes, FT8, JS8, and there's one from QRP guys in the States. It's $40 US. It's 3 bands on FT8, and you can just plug it into a laptop and have FT8 contacts on 40, 30 or 20 metres. Now the main problem with it is it's double sideband direct conversion, which means that the signal is double sideband, so you're actually transmitting 2 signals, a desired signal that everyone will be listening for you, and an undesired signal a couple of kilohertz away down the band. And the other thing is that your direct conversion receiver will be responding to signals a couple of kilohertz the other side of your suppressed carrier. So it's pretty much of a compromise, but as I'll mention later on, I have done experiments myself with homebrew gear, and it can work. The concept can work. Or if you wanted something only slightly more, 55 US instead of 40 US, thing called a phaser, SSB digital mode transceiver. It's again available as a kit. The only thing is it's only mono band. For a mode like FT8, you'd probably pick a band like 40 or 20 metres. And the other thing is that there are JS8 versions available. If you haven't tried JS8, a wonderful mode for QRP. If I've got time, I'll talk about that. It's a bit like FT8, but it's got many. It's a mixture of FT8, slow speed CW, packet radio, all these things in a not dissimilar digital signal to FT8, because you can actually have proper text contacts. Whereas with FT8, it's very much your exchange of call signs, signal report. I think it's grid locator, and that's it. You're in 15-second blocks. Whereas JS8, it's free text. You can type whatever you want, and you can if you go over your 15 seconds, then that's okay. You've got another 15-second block. and you can leave messages for people. You can do searches if there are people that are monitoring that might not be in front of their station. Then with JS8 you can put in commands and see what stations they've been hearing. You can leave messages through people, like if there's someone that you couldn't hear, then you might be able to leave a message for someone through another station. It's really, really smart features, and it's a free program. If you can use FT8, then and you've got all the equipment for that. You can also use JS8. The software is called JS8 Call, and I think their URL is js8call.com. Anyway, I reckon it's far better than FT8. It's got so many more features and it's far more personal. So that is a great mode for QRP, and now you've got transceivers like the phaser that you can buy and connect it up to your computer. So that's really exciting. That's only in the last maybe 6 months or a year. So it's one of the newer aspects of QRP. Another possibility is building yourself. There are a lot of designs on the web. A lot of them are designed or written by Northern Hemisphere people, where there seems to be more activity there. And here there are certain requirements, I think, that your rig needs to meet to have a reasonable chance of getting contacts. I think 7 megahertz is a good band to use, bearing in mind now that with the changed license conditions, Foundation licensees can now build equipment like this. And I think as for a requirement, frequency agile, really neat, as I mentioned before. You want to be able to tune the band, hear people calling CQ, tail end other people finishing a contact, give them a call, then chances are they'll come back to you and you'll get a contact. To do that, you need to be frequency agile to find stations to work. I think you need more than a couple of watts of power, maybe 1 watt on CW. As well, you need a direct conversion receiver that doesn't overload. The very cheap Pixie actually used the, I think it's the collector emitter junction of the final amplifier transistor as a diode detector, and it didn't have much of a front-end tuned circuit, whereas a better type of direct conversion receiver might have a double balanced mixer with 4 diodes, or even an NE602. They're not quite as strong as a double balanced mixer, but usually they're okay. So have a look for homebrew designs that feature either of those. There was a thing that I described on my website, VK3YE.com, and there's a big long video I did. In fact, it's like about 6 parts of it that describes what I've called the Beach 40. It's 40 metres, double sideband. You can buy pretty much all the parts in Australia, even the ceramic resonator you can get from mini kits in South Australia. The great thing about a ceramic resonator, you can get them for frequencies like 7.16 megahertz. You can shift it over like 100 kilohertz range of the band, or in fact more on 40 meters. So you cover pretty much all the SSB and 40 meters. So that you've got your frequency agility. It's tolerably stable on SSB, and with this, which is only like 7 transistors in it, I've worked into New Zealand and VK6 just on 40 meters. So that's a possibility if you wanted to build a simple QRP rig. Another possibility, something I've been doing a little bit recently. The great thing about home brewing is you might find something unusual in a junk box, and that just happens to be the thing you need. You might be browsing through that cardboard box over there, and again there might be a case, a plug, socket, component, board that you might have something, and that could get you interested in a particular project. So it's and of course you've got this wonderful institutions called tip shops that I don't need to. And I know there's one person in this room who I believe takes all the stuff so that the rest of you guys don't get a fair go. So yeah, lay off the tip shop and let a few people. Anyway, there's some amazing stuff in tip shops and things. So that's half the reason for you coming down here. So yeah, so yeah, you can. Some of the great things, you might come across something that's really cheap that just happens to be suitable for a homebrew transceiver. And one example, which I've described in this month's Amateur Radio magazine, and the thing you see there is that unit. JS8, I mentioned how it was a great mode for keyboard digital communication. and you could actually have chats. It's a bit like PSK31, but it's slower, a bit slower. It reminds me of slow speed Morse code. The transmitting speed is something like 12 words a minute, but it's really penetrates weak signal, poor conditions. A JS8 contact I was using the FT817, and then I was making contact to a guy in VK6 on 80 metres, and we thought we'd go down in power and see how low we could go, and he could decode bits of my signal down to about 30 milliwatts on 80 metres. So, and that's not a 2-minute thing on Whisper. This is actual text communication in a 15-second window on JS8. So it won't be quite as good as Whisper, but it is surprisingly good. And it gives you real-time keyboard-to-keyboard chats and all the other features. Anyway, possibility, and this could be something that could potentially be developed further to get foundation licensees on the air, especially now that they can use digital modes and homebrew gear. You've probably seen crystals in almost any old modem or computer board for 3.5, 79545 or 3.58, near enough. Anyway, with those crystals, TV color burst crystals, they're in the 80 metre part of the band, which is great, but as it happens, the JS8 centre frequency happens to be 3.578. So, great thing about them is you're very close to that crystal frequency, and if you put a few crystals in parallel and a bit of inductance in series, it's a little bit harder on 80 metres than on 40 metres. 7 megahertz crystals are easy to pull down, a bit harder on 80 metres, but still you can get 1.5 kilohertz lower down and therefore get yourself on 3.578. So you've got a very stable signal source, which can be your local oscillator for a direct conversion receiver. And that direct conversion receiver was what I described in the latest amateur radio magazine. Now, and I can't remember, it's basically like 3 or 4 transistors, and if you connected it up to your laptop with the JS8 program, then you could intercept JS8 communication with that setup. The other great thing about it is that if you've already got the receiver going, then it requires very little extra to make it into a transceiver. And so you've already got the local oscillator, which is the same frequency, it's direct conversion, so you don't need to change that. You've got the balanced mixer, which you can use that for the receiver, as well as a double sideband transmitter. So that's all there. Then the only other parts you need are a couple of transistors to give you a bit of extra as RF amplifier stages, and I've got on the front panel a switch. It's very crude. I should replace that with a voice activated relay so that then you can have all the automated features that JS8 allows, but with the switch on the front panel you sort of have to look at the computer screen, and when you go to transmit and receive, do it manually. But anyway, with a few transistors you can be transmitting JS8 with a very simple crystal controlled transceiver on 80 metres. I haven't had any actual contacts with it yet, but I have been detected in New South Wales on it, and I have detected stations on the receiver, so it's just a matter of time of me getting around and making contacts. But that is a very simple digital modes transceiver on 80 metres using a crystal that you possibly already have. So that's a possible, future project that could, be useful for QRP. There's not a huge amount of JS8 activity. It's mainly on 40 metres, much more on 40 than 80, but the propagation characteristics of 80, particularly at this time of the cycle, would make it great for communication within VK7 and across to VK3. Another important thing with QRP, I've spoken about the equipment. The equipment's only one thing. All your other considerations like your antennas and batteries can easily weigh more than your transceivers, so it's important to think about those. You want enough battery capacity to keep you talking for as long as you want. Now, personally, I like external batteries. Even though the FT817 has an internal battery compartment, I don't use it. I have external batteries, and you've got different choices. Probably the cheapest is the old sealed lead acid battery, the 12 volt 7 amp hour, super cheap. they're heavy. So that may not be a consideration, but if you're going on soda expeditions and every kilogram counts, then yep, it is a fairly, you might not want to use that type of battery. NiCad, they're okay, but limited capacity. Lithium polymer, special chargers. Apparently they can go bang if you don't look after them, so have a look on YouTube for videos of accidents with lithium polymer. Lithium ion as well, that's quite light and possibility if they're expensive but light, so that could be good for portable operating. As to what sort of battery you need, there's also LiFePO4, and that's the type that I use. A good compromise between them. A bit more expensive, their price is coming down, but they're quite light, so they're good for portable QRP. As to how much capacity, it really depends on your transceiver. It's worth drawing up a power budget to work out, okay, you might need to be operating for a certain amount of time. You also need to know how much current your transceiver is using, both on receive and transmit. And it can be surprising when you do the numbers, because most of the time you also have to estimate how much time you're going to be spent receiving versus transmitting, and it's probably going to be 80% or more receive, and that is why receive current consumption is so important to designing, working out what sort of batteries you want, because the receive current consumption, if it's like 1 or 2 amps, like it might be for non-specialised QRP rigs, that could actually be chewing up most of your battery capacity you have if you're running it for several hours receive. So that's why a rig like the FT817, which draws like 300 or 400 milliamps, that's okay in most cases. But even so, when you look into the current consumption of things, I think having rechargeable batteries has really desensitized us to how low a current you can build something and still work. If you look at consumer equipment like, consider a transistor radio from like 1960s, 1970s, just AM, maybe FM. There's no digital frequency synthesizer. It's just a manual, free-running oscillator. Anyway, something like that might only draw 10 or 20 milliamps. I have built receivers using the, it used to be called the ZN414. You can still buy it. It's called the MK484, and it's basically a receiver in a chip, 10 transistors, TRF receiver. Anyway, I built a receiver in that, and it draws something like 2.5 milliamps. And if you look at, and that's just off I think it's 1.5 volt battery. So if you work that out into watts, and you look at the amount of, let's say 1,000 or 2,500 milliamp hour of the battery, it will keep the radio going for something like 1,000 hours or something like that. And back when all we had was non-rechargeable batteries, the imperative was to build and design equipment that drew very little current, like just a few milliamps, like say 10 milliamps for a receiver. I've received amateur signals on homebrew receivers that have drawn less than 5 milliamps in a regenerative receiver. So you need to think about that. Okay, you might think the FT817 that draws 300 milliamps, you might think, yes, that draws a very small amount of current, and it does compared with, say, an ICOM 703 that might draw 2 amps on receive. But it's one of the joys of QRP is not only the low power in transmitting, but how little power you need to actually pick up very weak signals from the other side of the world on receive, and that's where homebrewing can come in, because you can build super low power gear, and that also goes into your power budget. Some of the commercially made QRP rigs I mentioned before have very low current consumption, so on receive. So that's might be a key consideration if you're looking to buy a QRP rig. Very roughly with the 817, 818, you would allow, yes, you could do a power budget, or I'd allow just under 1 hour worth of operating per amp hour with a dedicated QRP rig. If it was a higher power rig turned down, like a 100 watt rig turned down to 10 watt, they're horrendously inefficient. They might be drawing, I don't know, 7, 8, 9, they might be drawing 20 amps with 100 watts. You drop down to 10 watts and they might still be drawing, 7, 8, 9, whatever amps. So horrendously inefficient down on low power on transmit as well as receive. So that is a consideration if you're battery powered. First stage is to get your equipment that can draw as little power as possible, and draw up a power budget and allow a bit of extra, power budget. Like assume that you're only going to be using half your power, not your full power, so that you build in a contingency factor, and you'll never run out of power, or at least in theory. Of course, we all do. And then another thing to think about is antennas. A lot of people associate with QRP with poor or tiny antennas. But there's no reason why you can't have a big step IR and your QRP rig. It's perfectly legitimate. People say it's not in the spirit of QRP. They're completely wrong. Do whatever is your regulations, your planning permits, or whatever you can put up. No reason why you shouldn't be using a good antenna with QRP and get great results, including being, other people might think you're like a 100 watt or more station with a good antenna. It's worth looking at decibels and things and doing experiments. Of course, you've got a disadvantage of QRP compared with 100 watts. 5 watts versus 100 is like 2 S points below 100 watts, and you can claw some of that back with a good antenna and or a good location, or being there at the right time. It's probably easier to talk about antennas to avoid, because they're the antennas to avoid. They're the ones that for some reason have got a big loss that can make your QRP less than pleasurable. So I find that it's hard to make an antenna that's much better than half-wave dipole, but very easy to make one that's inferior. So dipole will work quite well. No relationship between cost and performance. In fact, expensive bought antennas, they are products designed to meet a particular solution, and there are obviously enough suckers out there willing to, obviously people that don't buy my books, who are willing to buy some of them. Maybe it's for legitimate reasons, very little space, but some of the really compact antennas do have a severe performance compromise, especially if they have to cover multiple bands, and especially if you want an antenna that can cover those bands without having to readjust something on the antenna or retune it or whatever. People love the idea of something that does 3 to 30 megahertz without having to tune on their transceiver. However, there can be severe compromises, especially with smaller antennas, if you go down that path. I find dipoles shorter than 3/8 of a wavelength, even if they're tuned feeder, the losses can pile up. That means for 80 metres, if it's less than 30 metres from end to end, I've found that the performance does drop off significantly. G5RV is okay, but if you try to use a 40 metre dipole on 80 metres, even if you're feeding it with tuned feeder, I find it doesn't work very well at all. But when you go above magic 70% of full size, then the performance really starts to improve. Another thing that's a risk are short end-fed wires. Like trying to load up 10 metres of wire on 80 metres, it might be better than mobile whip, but it's very much a compromise, especially if you've got a poor ground. Grounds everything with short end-fed antennas. So that's a real, if you can get to half a wavelength or even 3/8 of a wavelength end-fed, then you can take a few more compromises with the ground and still get contacts. Another thing I suggest avoiding, particularly for portable operating, antennas with lots of parts to go hissing. Like there's one, like you see mention of a thing called the buddy pole, and I've seen one once or twice, and there's all these little fine adjustments with taps and things on coils, so to change bands be quite awkward, and you're sort of telescoping lengths and things just to get things onto resonant frequency. So if you're setting up portable and and the rain's coming in or it's getting dark or whatever, if you've got an antenna that will it only takes 5 minutes or less to dismantle, then you'll be very thankful for that. The other thing is antennas that claim small size wide bandwidth, high efficiency. Yeah, you can have two, but you can't have all three. No one's invented the miracle antenna that does all three, so you have to compromise on one of them. And with QRP, since you can't compromise too much on performance, bandwidth is probably the one you want to compromise on. And another thing is anything that's too heavy or complex, like traps, loading coils, etc., for portable operating, especially if you're using squid poles for antennas, because you can buy the lightest, thinnest type of hookup wire and you can put that on a squid pole fine. But as soon as you have traps and loading coils, because the squid pole, so the tops of them are like 1 millimeter in diameter, they're very fragile and they will just bend over and reduce your height if you have any weight on them. Therefore, good idea to avoid traps and loading coils that contribute that weight. Another thing I'd steer clear of is antennas with resistance for broadbanding, as a resistor will, depending on the frequency, will chew up a bit of your power, which you can't afford. Antennas I've used, if you've seen some of my videos, I've used quite a few of them. The one I come back to a lot of the time, particularly on 40 metres, particularly if I'm not hugely seeking DX, an in-fed half-wave wire, about 20 metres long, and an L-match antenna coupler. L-match is really easy to make. It's a lot smaller and lighter than a length of, say, RG58 kayaks that you'd otherwise need. It can work on multiple bands with a coupler. You could, if you wanted to, tap the wire for different lengths if you did want to run a half wavelength on 20 metres rather than a full wavelength with your 20 metres of wire. But yeah, overall I've just found that about a half wavelength on 40 metres works quite well for some of the higher bands as well. For 80 metres though, I would prefer to add a bit more extra length. If you can add another 20 metres to make it half wavelength there, then that's probably a good thing. Another possibility, particularly for DX, is a full wavelength delta loop, a third of a wavelength per side. You can just have a single support, so you have a triangle like that. If it's over the water, I'd suggest feeding it a quarter wavelength down from the apex to the top, so it's a 12th of a wavelength above your bottom corner, so you've got a feed point quite near the bottom, which is handy mechanically. But that gives you vertical polarization, which, especially if you're over salt water, you can set it up on a pier and that can give you quite good results. That antenna can also be multi-band. It can be. Especially if you feed it with open wire line, you can tune it for multiple bands. It doesn't have to be a full wavelength around. It can be a little bit under. Like a full wavelength delta loop on 14 megahertz will work fine on 10 megahertz, 30 metres, where it's about 2/3 its size, but I wouldn't use it on 40 metres, its efficiency will drop off. But if you wanted to try it on 15 metres and your antenna coupler works okay, then it would be okay there. Another possibility is, it's very simple to put up, is a vertical on a pier. A normal squid pole might go 9 metres tall, which is near enough to a quarter wavelength. Especially if you've got an antenna coupler. Aim for between about a quarter wavelength and 5/8 of a wavelength in its length. Half wavelength vertical is fine. That is very high impedance, so you will definitely need a L-match antenna coupler for that. And you can just have a bit of thin wire up a squid pole, and you can get squid poles between 5 metres and 9 metres. Another possibility, centre-fed dipole and variance. Very simple, basic, nothing wrong with it, especially for a single band. Linked dipole is great for multiple bands. Main problem is you have to, not so good for a contest where you're having to change bands a lot. So for casual SOTA or parks operating, a linked dipole is great. I think most people into that use it, where you're only occasionally changing bands, but for a contest, if you're changing bands more, then there's other antennas you can use. Traps and loading coils, yeah, they do work, but they add bulk, which can be a consideration if you're using a squid pole wire. Tune feeder dipole is efficient, good over multiple bands, but requires a balanced coupler. Although having said that, I did a video recently where I tried an unbalanced coupler, an L-match, and it still worked. But ideally you want balanced antenna balanced feed line, balanced coupler, ideal. And then there's other possibilities like half square and bi-square. Now, bi-square is a huge antenna, even for 10 metres. It is, you'd almost think it was like a quad loop, but it's not actually a single continuous loop. It is split at the top, fed at the bottom, and it's the same size as it's basically 2 wavelengths of wire. It's got a little bit of gain, but it's massive and it requires a huge pulse, so I wouldn't necessarily recommend. In contrast, the half square, especially if you're down by the beach and want something that is not very high, maybe you've only got a couple of 9-metre squid poles, not very high, vertically polarised, low angle of radiation, a bit of gain, broadside, half square is a good antenna. All it is again our magic 20 metres of wire, very useful length, but this is on 20 metres. It's full wavelength of wire. You basically have a quarter wave length up, which is only 5 metres if we're building one for 14 megahertz, half wavelength across, so it's 10 metres across, and then another quarter wavelength down. So it's 20 metres of wire total, and that will give you quite a good antenna on 20 metres. You'd feed it with a little L-match antenna coupler, as it will be, it's 1 wavelength, it will be high impedance. You can have a small ground counterpoise, something like that. And particularly near salt water or over a pier, that is quite a good low angle DX antenna. So the other thing about it is it's only a quarter wavelength high, so potentially if you had a 10 metre pole, you could make one even for 40 metres and you know, to get your quarter wavelength, and it would be okay. There's for materials, you don't need very many materials, but I reckon a squid pole is pretty key. Yes, you can throw things up over a tree, but the problem is you really need to know your site. There might not be very many trees where you're operating. It might be a public area, and people don't like you know, if you've got people don't like you seeing things throwing stuff over trees. So where I am by the beach, you know, the trees are only about this high, so a pole is a great accessory to carry along. Preferably one. There's a much wider range of antennas you can build and erect if you have 2 squid poles, doubles the weight, so it's a bit of a trade-off there. Some other useful bits of things, plastic kitchen chopping board. Now, there doesn't seem to be anyone a chopping board here. Maybe someone's pitched it for an antenna.
Terrific use.
It's a really good material, and I don't know about tip shops, but op shops. You know, look at op shops and things, because some of the chopping boards new, some of them you see can be like $5 or $6, which is you know, too expensive, and you can find a worn one in an op shop for like, you know, maybe $1. Maybe in Tasmania it would be 50 cents. Or is there a Tassie tax where things are more expensive here? Or,
yes.
Now, is that true on second-hand things, or are second-hand things cheaper?
Depends on the tip shop.
Yeah. Okay. Yeah. Now, are tip shops dearer than the Salvos or the Red Cross?
Yeah, becoming.
Okay. So tip shops are for gentrified people like you. Okay. All right. Okay. So it looks like the op shops where you go and get chopping board. So get some chopping board, and they're really easy to work with. Get a hacksaw and chop them up into little bits. They work quite well as spreaders for open wire feed line, which is great, or antenna insulators or centers for dipoles. Great. Even lighter. You know, and I hear that, you know, Hobart's going through a bit of a property boom, so you might not be seeing them on too many houses for long. But those plastic core flutes, if a house sells in 5 minutes, then just find the core flute pointing to the house and souvenir it and
Flog it.
Yeah, and cut it. Cut it into lots of little bits, and then you have a super light, super strong material for making spreaders for open wire feed line. It's even thinner than and lighter than chopping board. It's surprisingly robust and strong material. In fact, I built an antenna coupler using core flute material, and I used a variable inductor using a ferrite rod from a radio that slid in and out of this core flute, because I was able to get these these scissors. Only certain types of scissors worked. They need to be really thin, pointy scissors. But anyway, I could cut through some of the sections of the core flute So I was able to merge some of the holes, and that provided a tight fit on the ferrite rod. And then I drilled with 1.5 holes or so, the same drill bit you use for your printed circuit boards. You just drill them maybe 10 holes or so either side of the hole that you've made for your sliding rod, and that will make you a continuously variable inductor just by sliding the you won't get a huge range. I think I got about 1.5 to about 5 or 6 microhenry, but that variable inductor is enough to make a L-match antenna coupler for 20 metres, 40 metres, and a few of the bands. So core flutes are, people talk about roller inductors and all that. For QRP, you can make your own with a core flute that you swipe from the real estate. So and a ferrite rod. So yeah, good material. Fishing line as well. Velcro strip, a roll like that. I don't know if you can get it from Bunnings. You can certainly get it from eBay.
Electrical wholesalers.
Yeah, but you can use that to lash your squid pole to your fence railing or something. Thin hookup wire, preferably copper, but thinnest stranded wire, like cheap stuff that JCar sells. So when you go and buy my book, you also buy some thin hookup wire from JCar, and that will be fine for an end-fed wire antenna. There is also other types of wire, like that green gardening wire stuff. Now, it's not copper. I have used it as an antenna and it does work. It's a bit rigid. If you're really stuck and you'd left your wire at home, then yes, you'd use it, but otherwise just a temporary thing. Like if you sometimes see that sort of wire at $2 shops or whatever, and that's a possibility. I've spoken about telescoping squid poles. There's different lengths you can get. There's 5 metre lengths. Some of them collapse down to this short. In fact, I think there are even lengths of like 8 or 9 metres that have multiple sections that again collapse quite short, and that could be useful if you're travelling. As for things to avoid, at least for HF QRP, if you can avoid coax cable, particularly RG58 or thicker, that adds a great deal of weight to your pack. Bulky antenna couplers, they're great for high power in the shack, but for QRP they can be bigger than your transceivers, so not ideal. Bulky VSWR meters, what you've got in the 817, it's only a relative reading indicator, but that is fine. Heavy balance, no, I don't need them. Antenna analyzers, don't worry about them. Basic thing is question every gram. Does it add to your signal or not? There's some people that take accessories like things like Morse keys or bulky headphones or other things, and the question is, does it add to your signal or not? If it doesn't add to your signal, leave it home. As for supporting antennas, I've mentioned squid poles, or you could just use fishing sinkers and throw line over. People might not like that, so might not be a good idea. I have tried kite antennas. A single kite can support, say 40 metres of wire, and it can give you great results on a band like 160. Sometimes it's difficult, depends on the kite. Sometimes it's better if you're a two-person operation, so you've got one person to look after the kite and the other to do the operating. But there have been times, some kites, there was a kite that Audi sold that was like $6 anyway, one particular type. It stayed in the air for something like 40 minutes or something, and I could operate and had quite a few contacts with it. So then there are other types of kites that compact, really small, that don't have metal frames, that's sort of self-supporting. A guy in America was very generous the other month, and he sent me this kite. There's this huge mailing tube arrived at my front door, and anyway, wondered what was in it. And there were all these metal boxes of M&Ms. That was what was contributing most of the weight, and all these other lollies and things. Of course, they were eaten first. I think the idea of the metal boxes was as projects and project cases, and anyway. But really, the main thing that he sent was this kite, which I did a video a couple of months ago on it, and it was surprisingly good actually. It was a frameless kite, so if you're into something really light and compact, then that is something to consider. I wouldn't have any more than 5/8 of a wavelength of wire on it, otherwise the radiation pattern changes and becomes higher angle. Good idea, even though there's not a thunderstorm present, you can sometimes get static and things off your wire. Good idea to have a bleeder resistor going down to earth, say 100k or mega ohm, something like that. Of course, the other thing is you need a large open space, otherwise your kite will be caught up in trees and public areas. So that's a main limitation. So for something like SOTA, probably not. But if you want to do tests on 160 metres and DX, and even early in the morning, provided you've got the wind, then the kite is a great antenna, as Marconi found. And the antenna, second from the bottom, that is actually a half square that I described before. 2 poles, 1 wavelength apart and a quarter wavelength up.
If you're using the kite as a quarter wave, you've got to put a ground.
Yes, you do. So that's where sports ovals can be good. Like there was some sort of soccer net thing that I used. This is on 160 metres AM. Like there's a session in Melbourne, 11 o'clock. Monday to Saturday, 160 metres AM, and people can get on. And there was a guy who recorded my signal from, I don't know, it was like 50 kilometres away, and the kite was up, and and this is just with 10 watts from a converted CCOM. I was a huge signal, like a broadcast station, way stronger than anyone else, and then the kite came down, and just the signal just dropped down to nothing. So, can definitely an efficient antenna if you can. As far as matching the antenna goes, you can feed it with coax. Good for a single band, multiple bands. Less so. It's RG174 can save a lot of bulk. Its loss, it's tolerable on the HF bands. VHF not so much. A small antenna coupler though, something like this, you could build something small enough to plug in to the antenna socket on your transceiver, or you could even build, if you've got a single band QRP rig, you could even build an L match straight into the back panel of your QRP rig. You could even have a little switch and 2 antenna, a couple of binding posts, and be switching the antenna coupler in. Like all it is, like for 40 metres, if you're just using a half wavelength of wire, you could probably have a fixed inductor of about 4.7 microhenry and a variable capacitor like a transistor radio type, and that will match a few antennas. I've described a few antenna couplers. Another possibility, I've used the small RF chokes that you can buy from Altronics and J-Car. They do work, but I found on digital modes with 5 watts they can burn out. Especially at 100% duty cycle. SSB is a bit more forgiving. Another possibility is to use toroids and have switches shorting across them. You could have, it's not quite as good as a roller inductor, but pretty good. You could have a switch, 0.5 of microhenry, 1 microhenry, 2 microhenry, 4 microhenry, 8 microhenry. That gives you 8 or 16 steps, like binary steps, so you can get very close to spot on, especially in conjunction with the variable capacitor, so that's a good approach. Automatic antenna couplers, personally I suggest avoiding them. They're expensive for what they are. You'll get no better results than with something that requires 2 or 3 components, and they won't necessarily match as wide a range as with a manual coupler. And also they don't contribute a single dB of signal. You're better off spending your money on a taller mast. I've talked a lot about the station. What about making contacts? Now, some people, of course, don't have success with QRP. It can be due to a lossy antenna, bad choice of band or frequency, poor operating. It can sometimes be, sometimes people, if you're very new, foundation licensees might have difficulty with 10 watts. I talk about that in a lot of detail in this book, as well as in my book, Minimum QRP. But basically, important thing, tune the band first, get an idea of the general conditions and where it's open to, take note of any beacons and call signs, look people up where they are, and then you'll get an idea of the conditions. You tune the band again, then you're more attentive, especially you want to ideally be listening for stations calling CQ, which you probably won't hear anyone. Then there might be others that are about to finish a contact. So take a note of that frequency, because that could be useful later on. Or maybe there are people that are making really quick contacts. Again, that could be useful later on. They present opportunities to call stations that you know are listening. So best ways to make contacts with QRP. First of all, if there are any CQ people calling CQ, then obviously try to answer them. If there aren't, then next tail end contacts, because you know that there's people normally don't switch off immediately after finishing a contact. So that's why it's so important to listen for contacts about to finish, because you need to be and be tuning across the band and just see how the contact is progressing, and so you can be right there when the contact finishes, and you can pounce in and call someone. And then as well, people making very quick contacts, again, there's an opportunity for you to jump in. Timing is really important. On one hand, you don't want to delay yourself so much that you're not talking at all and everyone's switched off, but you don't want to be talking over the top of other people. Some people do not necessarily end contacts very cleanly. Some people can take 10 minutes or more to say 73. It's amazing, but so you have to develop an art through practice and listening of timing. So it's no good with QRP talking over the top of someone else, because if you're the lower power station, then others will probably be stronger. So the trick is that other people are listening and you're in the clear. Then once the contact is established, first thing is you've got to get your call sign across. Do not and make sure the other guy's got your call sign right. If you don't have your call sign across, then it's not a valid contact, and they might be giving other information like their name or whatever. Don't give your name or anything else until you know the other station's got the call sign right. Then after then you can. But call signs exchange is absolutely important, and you keep repeating it until you get through. Frequency agility, as I mentioned before, is absolutely king. Generally with QRP, you must find and call people often on their frequencies, rather than expecting them to find you if your signal is weak. So that's why frequency agility is so important. As for conditions, are they really that bad? Long distance DX is hard. That's more than 3,000 kilometres. But still, there's a lot of people less than 300 kilometres. ZL, other VK that you can still hear and work. Digital modes offer an advantage. Grey line on lower HF bands early in the morning, or around sunset as well. You can still easily make, just even though you might officially have a sunspot count of 0, you can still easily work 3,000 kilometres on 80 through to 20 metres. Just be aware that bands like 40 metres during the day, you don't get your closer in stuff during the low sunspot period. Whereas when I came here about 5 or 6 years ago, I was on 40 metres and working people all around VK7. In fact, there was a surprising number of VK7s on the air on 40 metres. But now with the longer distance propagation, you might hear people in South Australia and New South Wales more than others on 40 metres. So you've got your changes in your skip zone. So a band like 80 metres might be better. And I've done surprisingly well, working to even 80 metres during the day. Not many people on it, but that has a lot of potential, including with, say, that digital modes transceiver could be quite good, I think, for 80 metre contacts within VK7 during the day at the current phase of the cycle. Then, of course, and we're at the tail end of summer, but there's still activity on 10 and 6 metres. Can be great with QRP. That's still active with some great contacts. There's a guy from VK3YE who's got a little handheld, and he came down to VK7 a few weeks back, and he was easily working people on the mainland just with a handheld on 10 metres. And of course you can, and quite a few people in this room know, you can still work a lot of VHF, UHF microwave. So still lots of opportunities for QRP, even if you've got sunspots of 0. HF Pedestrian Mobile, I live by the beach, so it's great to have salt water around, and I've done a bit of Pedestrian Mobile, mainly using 2 types of antennas, one a magnetic loop and the other a vertical. 40 metres overall, there's best band for contacts within VK. Bit of a novelty as well, and which I enjoyed. 20 and 30 metres can be good. I have worked across to the States and Europe on 20 metres. Again, this was a few years ago when conditions were a bit better, while I've been pedestrian mobile on SSB on 20 metres, just running 5 watts. 80 metres, I've tried it, very difficult, but still need more refinement in the antennas. 10 metres is fantastic for pedestrian mobile this time of year. And also 6 overall, if you were to choose between one of the bands, I'd go with 10 metres. More people on it and more activity, but yeah, 6 can be a lot of fun as well. Even 2 metres, 70 centimetres SSB, you can work pedestrian mobile, and you will get questions from passers-by, so be prepared to answer those. But part of the fun of it as well is the novelty factor of the guy on the other end. You're probably going to be the first pedestrian mobile station they've worked on HF. Yeah, that's our 2 antennas. It's a magnetic loop. It's made from aluminium strip you can get from Bunnings. I think that's a 3 metre length, so I didn't need to cut it. You just bend it into a thing that looks like a giant stop sign. And that will work on 7 foot at 28 megahertz. There's a variable capacitor at the top. If you wanted to cover the higher bands, like for the sporadic E season over summer, then it's good. It's worth having a smaller loop as well, which is a little bit less unwieldy, about 40 centimetres in diameter. Another possibility. This is fine if you are, if you're not by the beach, if you're just an ordinary suburbia, because you're not having to worry about ground, whereas the vertical is better if you're over the water, because ideally you need your earthing thing to be in contact with the water. And this is 5 metres of a wire. You can't see it, but there is a loading coil that I switch in. The 5 metres of wire is fine for 10 megahertz through to 50 megahertz with a little L-match antenna coupler, but for 7 megahertz it's not long enough to be efficient. But I did find that a small loading coil, it's centre loaded, that works, that allows it to work quite well on 7 megahertz. So I've had contacts into New Zealand, 7130DX net, most people will hear you at least within that range with this sort of setup. So that can be a lot of fun, and there's video demonstrations of it. If we've got some time and if we're connected online, I can give you a demonstration of some QRP contacts. I'm not sure if that's a hyperlink or not.
Yeah, no, it is. I'm just going to get you some.
You need some audio.
Because they're quite small speakers. Just.
Thought I had a hold on those.
Kidney speed. There we go.
There's something. Maybe it was at the tip shop for a reason.
QRP audio.
Let's go. Hang on, a bit.
Maybe we'll go back to the.
We start?
Yeah.
Just grab it back. Cool.
kilometres plus. It's a commendable effort.
160 metres AM.
Yeah, thanks, Eric. There are further distances between any stations here. Also,
The kite's down there.
From Peter VK3YE.
It's almost new, isn't it?
I've just dropped the power. Okay, we're now running at 500 milliwatts. Okay, you're fine at Peter, drop back to about 555. Okay, clear, go. Roger, Roger. You're a 5.9 and running 5 watts. 5 watts QRP, over. Okay, ready to for 5 watts. How many thanks for the call? Thanks. All QRP, positive about QRP. Alright, good agree, George. QRP, positive about 5 watts. I am QRP 5 watts, 73. No QRP, no QRP.
Yeah, so sometimes you get
He had a bit of difficulty.
doubters like that guy there. So yeah, hang on. I think there's next to another page.
When you're wading through the water with the squid pole on your back.
We're about to summit.
Whoops.
Turn around.
Hang on, is this another video?
Let's go on to the next video.
That's you, yeah?
Just close.
Summit to right about. Just a little bit of a cloud there.
And we'll go back, catch up alpha. Now we were about. There we go. Okay. All right, so that's gets pretty much towards the end. Basically, summary is QRP works most of the time with pretty much all facets of amateur radio, and maybe EME might be a bit of a struggle, but otherwise, most things.
Yeah.
3 milliwatts.
3 milliwatts. Well, there you are. Equipment's plentiful and cheap. Operating technique really important.
Carry that on your back.
Yeah, operating technique really important, and there's various activities you can do. Means that it's not barely affected by the sunspot cycle because there are a lot of other frequencies and bands and options. For further information, there's a VK QRP club I'd highly recommend. $15 a year membership, and you get the 4 magazines per year. Some people in here might be a member. So, yep, based in VK5, they've also got a page on Facebook. So join. Look at the VK QRP club. There's also my website. There's a bit about QRP at VK3YE.com and my YouTube channel. I've written a few books about QRP. Probably the one that's most that elaborates a lot on this talk is Minimum QRP. That's a lot of not many circuits. I don't think there's any circuits, but there's a lot on operating techniques and the various things you can do with QRP, ideas for antennas, etc. For more detail on the antenna side, which is important, there's hand-carried QRP antennas. It's been a huge. Both these have been huge sellers. Thousands worldwide have been sold. Both these books, and just recently launched in the last month or two is a successor to hand-carried QRP antennas called More Hand-Carried QRP Antennas, and that is more practical side, particularly the higher HF bands like 28, 50 megahertz, lower VHF bands. That's some of my more recent antenna experiments. So some of the antennas I've described here have been very simple little oblong loops that I've tried with Whisper with quite good results on 2 meters. So that's books I've written on QRP. You can have a look at them through my website. There's reviews of what people have said about them on Amazon, so you can get them as an ebook or in other countries as paperback as well. The other thing as well, and which we can get as a paperback, our JCar stores, is the Australian Ham Radio Handbook. It's pretty much takes off from where the Foundation License Manual finishes. Foundation License Manual is great for people getting their foundation license, passing the test, but it doesn't go a lot further than that, whereas this book pretty much covers you a lot about very, as the title suggests, very Australian based. Dick Smith actually wrote a very similar book about 40 years ago. You might have seen it, called the Dick Smith Australian Amateur Radio Handbook. It's a big seller. You might sometimes see them at Hamfests, and this book is a similar type concept to that, but updated for 2020 or 2019, and it gives you a lot of the different facets of amateur radio, very Australian focused. There's a lot of Australian specific details, like all these obscure suppliers you probably haven't heard of are listed in here, basics on setting up a station, stuff about clubs and Facebook groups where you can find further information, a lot about operating and getting contacts, repeaters, satellites, various facets. So that's you can get it as an ebook, again via Amazon or from JCar as well, for $24.95. So really pleased that we've now got a locally produced Australian amateur handbook, and it's so widely available. So that's something that you could be interested in. Okay, do we have any questions?
Do you get any funny looks when you're walking with a squid pole through the water?
Yes.
Yep.
And it's funny that people ask you whether you're looking for aliens, or whether you're a spy, or whether you're a terrorist. My answer is yes, of course.
You ever been accused of electrofishing?
No, but I think someone thought I was tracking animals, and at one time.
I noticed you had earlier there, and I came in a bit late, so I'm not sure if you already covered on, but you were talking about half-wave end-fed antennas. Have you had much success with those, especially when they're not necessarily as high as they optimally should be?
I've had overall half-wave end-fed's my favourite antenna. For 40 metres particularly, I found they work quite well. Generally, the height I usually use is I have them like an end-fed inverted V, so in the middle, which is the highest point, is about 8 or 9 metres tall, which is where the squid pole is. I haven't tried them really low. I suspect that performance would be a bit less when they're lower, but Yeah.
So when you said the middle is, so you put an end fed up as an inverted V?
Yes. Because that's the easiest, because you can tie off the end to a tree or fence or whatever, and the other end of the inverted V is where your transceiver is. So you just have the pole in the middle. So yeah.
Is it necessary for them to be particularly straight, or does it not really matter that much?
Well, it's not straight. It's sort of like an inverted V. So yeah, no, that doesn't matter too much. It's
Good on top of a mountain.
No,
yeah.
no, somebody might have noticed that the 160 metre end fed we have here is hanging a bit low tonight. I don't know what's happening
160 metres is a different. 160 metres is a different kettle of fish, because your propagation mechanism, like if you're trying for like the end fed I normally use on 40 metres is fine if you're trying to work people from, say, there's a big band of distances on 40 metres which are really easy to work, like depends on the solar activity, but it might be, say, 200 to 1,000 kilometres, and that band relies on a relatively a medium to high angle of radiation and from your antenna, whereas 160 metres, it depends on whether it's during the day or at night. If during the day you want a vertical antenna for ground wave coverage, like what the AM stations rely on, and for DXing, vertical for long distance, low angle stuff is good. Whereas a horizontal dipole or horizontal end fed for 160 might not be so good. It won't be much good for local ground wave stuff, and being close to the ground, it won't necessarily be very good for DX, but there'll be certain intermediate distances of maybe 200 kilometres that I've had that type of antenna will work quite well on 160. So 160 is a bit more selective. I find, like, depends on the distances you want to work and the propagation modes as to whether a horizontally polarised end-fed antenna is a good choice or not.
Can you describe the way tenor? Because you've obviously got something, the ground that goes down to your...
Do we have a whiteboard behind it?
Yeah, just unhook it down the bottom and that'll disappear. And I'll switch it off here.
Another down and up.
I'll take a blind. No?
Cool.
Okay, now, is all this important?
Probably not.
Okay.
You can
The center bit could probably go.
Yeah, it can go.
Then again.
Oh, what does that say?
Oh, rugby.
You can rewrite it.
Okay, we have. Okay. Right. Okay. Low tenor. Basically, the basic form is, ignore the switch there. It's 5 meters, which is a quarter wavelength on 14 megahertz, half wavelength on 28 megahertz, and intermediate on other bands. There's an L-match antenna coupler that goes to your transceiver here, and so it's your basic end-fed wire. Now for the grounding thing here, all we've got is just a bit of hookup wire. This is I think it's a poached egg ring, but anyway, it's an aluminium thing about this big, and I sort of slot in it, and the idea is that it is held underneath the salt water. It's really important that it does make contact with the salt water. It doesn't matter whether you are, so the idea is that you wear that around your ankle, and then you have your transceiver in a bag. Of course, your transceiver must always be above the waterline.
Why?
And then you have this assembly in a backpack, and that's where I actually used a chopping board that I did not chop up inside the backpack, and then I attached that to a bit of conduit, and into that conduit slides a telescoping screw pole, only about 5 metres, so it's a shorter screw pole that collapses down to about that much. So that fits in your backpack. In fact, it fits in that backpack there, and and you wear that on your back. So that's where your antenna is, and so you've got your little antenna coupler that connects straight to the antenna socket of the FT817. Uses the front socket. I don't particularly like supporting things on the front socket of an FT817. You shouldn't do it unless it's very light, which this coupler is. It's just built on a few pieces of circuit board, and there's a rotary switch here and a toroid inductor, so that's just an L match. And yeah, this is held in the salt water, and it's just one of those Velcro strap I mentioned, just tied around your ankle, so you need to be walking through the water for it to work. If you are, and I find it's particularly important on 40 metres, 40 through to 20 metres, the lower HF bands. It makes a huge difference if you walk out of the water. The signals drop hugely. It could be like 3 or 4 S points. And it makes a huge difference between people, whether people can hear you or whether they cannot hear you on 40 metres. On 10 metres, it's not so much. Bearing in mind, on 10 metres, this is a half wavelength. As I mentioned before, for 40 metres, that's one thing about it, is that the 5 metres is only one, it's 1/8 of the wavelength on 40 metres. I've got a centre loading coil, which is actually just a bit of plastic conduit with some hookup wire around it, and that just slips over the pole as well, and there's a switch across that, so it's only on 40 metres that I have that coil switched in, otherwise I have it switched out. And so yeah, as soon as you walk out of the water, it makes a difference. Another difference is that if the sole of your foot's on wet sand, it's sort of, the signals are choppy. It's almost like a 2 metre FM signal that's noisy. When you're not touching the sand, the signal is weak, and when you are touching the sand, it's stronger. But it's therefore you need to be walking through the water for it to be consistent. But yeah, there's but if you come to a pier or something like that and there's railing, then you can just touch that onto the railing of the pier, and you'll get a similar result to if you're walking through the water. So that's an option if you have a pier with a metal railing.
When you say walking through, you could be standing still.
Yes. Oh yeah, that's fine. Yeah. Yeah.
It's cold though.
Or you could have one on both ankles when you're walking along the sand.
That's true, but it's really a very really very poor performance. Yeah, the sand's a bit stronger, but it's really better to be in the more ankle to knee deep water. It's,
I think you commented in one of your either write-ups or a video that you were getting a little RF buzz at some point.
I don't think I did, no.
Oh, okay.
Someone might have commented on it, but no, I haven't felt anything.
Okay.
And I wouldn't recommend this for anything more than QRP.
Yeah.
And probably a low duty cycle mode like Pedestrian. I haven't tried Pedestrian mobile slow scan TV, but
that's the next challenge.
Yeah, I just don't like the idea of dropping phones and things into the water. Possible variant of it, and people have had good results, is some sort of ground tuning unit where you've got a counterpoise and then I think it's a series tuned circuit, and you tune it for maximum current, so you could have that suspended above the water. But overall, that's better than a magnetic loop if you've got access to the water, particularly for 40 metres. In fact, I think it's close to being, the performance is close to being a full-sized antenna on 40 metres, because particularly for some of the longer distance stuff like VK3 to VK2, there's been times when I haven't heard the VK2 call back all that well, although they've heard me, and I think it's because this might have a lower angle of radiation than, say, a low horizontal antenna. So for that distance of 1,000 kilometres, this might start to come into its own as being a better antenna. So yeah, I have worked into Europe on, not much recently, not at all recently, but to Europe on 20 metres with this arrangement. I haven't really sought a lot of DX. I have done contests like John Moyle RD contest with this arrangement. The main problem is, it's easy to get the contacts, logging is the problem. So yeah, it's.
Is there a reason why you don't just drag the wire in the water?
I have tried it. Dogs go chasing after it. When you drag it along the sand, in fact, the first thing, I did some videos on this, the first thing, before I had this, I did have a wire trailing behind me, but I found that ground characteristics of the sand, if it's dry or wet or whatever, meant I was always adjusting the antenna coupler. Whereas with this, with it being in the water, it's a constant setting, so I didn't need to
Attach it to a dog collar as he paddles through the water.
You could, yes,
Yeah.
and then of course he'd run away and get excited, and your transceiver would go off.
Have you ever thought of taking that exact same rig and transferring it to sitting on the bow of a tinny?
That would be good. Yeah, it would work extremely well. No doubt.
You just have to attach the ground.
You just
to the
got
tinny.
to
Yeah, you just attach
to
it.
the tinny.
Yeah, no, it'd be fantastic. You'd do extremely well.
Well, I was wondering, at what point does the proximity of the lead and the bow of the tinny start to come into play when you're starting to get a bit lack of separation between the radiating side of the antenna and the ground?
Yeah, I'm not sure. Yeah.
What sort of results have you had with the magnetic loops?
Pretty good. If you're not near a beach and if you don't have a very good ground system, although magnetic loop is a compromise, a vertical relying on a very poor ground system is probably even more of a compromise. And there's I know that VK5 SFA has built this huge magnetic loop, wonderful, and I've heard him on a crystal set with I think on 80 metre. Admittedly, I think it might have been a one transistor audio amplifier attached with it, so it wasn't a pure crystal set. And then I had this BFO as a local oscillator, so I could hear his SSB, but I could hear him on that. So if you go to a lot of trouble, basically conductivity is absolutely key, minimising all your DC losses. That means really good engineering, and that can sometimes conflict with the requirement to be light and hand carried for QRP. Still, for pedestrian mobile, if I wasn't by the beach, I would just be using my magnetic loop. And I've had some good results on 40 metres and 20 metres carrying the magnetic loop. It's also much safer in a residential area. Like with this, you'd never use it in a residential area because of power lines and trees and other things, whereas the magnetic loop is much lower, and you can also null out interference on the receiver, which is good. So yeah, it won't be as good as a full-sized antenna unless it's really well engineered like the VK5s, but for pedestrian mobile it's been quite good.
You mentioned squid poles. I have purchased a couple from Haverford.
Yes, yep.
And they make a multi-purpose one.
Mm-hmm.
And rather than being 1.5 or 2 millimeters at the tip with a little sort of eyelet for the fishing line, the top is actually 8 millimeters.
Okay, yeah.
And it's really rigid. I've got a pair of them. I have a full length of wire going into a multi-band automatic antenna tuner. It works reasonably well. Just stuck in the backyard.
Yeah. So that would be a good choice if you're, if you've got trapped dipoles or something with coax feed line, or maybe something with a bit more weight. But yeah.
I'm planning on using it and getting a little wire up in a tree where I'm.
Any further questions for Peter? Can we show our appreciation?